Let's begin our class now. Today's class we will discuss work, energy and power. And this is our main topic for today's class. First of all, I will explain you some important concepts and then we will use those concepts to solve some problems from past papers. So first of all, we need to understand is what is work done. Work simply we can define work is equal to force time distance moved in direction of force. Distance moved in direction of force. We can say distance moved in direction of force. Moved in direction of force. So this part is very important. Distance moved in direction of force. So this is you need to understand. And also the unit of this one, unit of distance of work is joule, and simply you can write down W is equal to F times T. So this is how you can write down work done. Okay, so this is how we can write down work done. So it simply means that imagine that we have this one box and this is placed on the ground. So simply you can imagine. And if I apply force F on this one, let's say we apply force F on this block, and this block, let's say, cover this certain distance. Let's say it's cover distance from here to this point here. So what is the work done? Work done is simply force time distance. This is the distance. So W is equal to FD. This is what you need to understand what is work done. So you need to take distance moved in direction of force. So that's main point. Let's go to next one. Next thing you need to understand about kinetic energy. How we can calculate kinetic energy. This is equal to 1/2 mv squared. So simply you can imagine that if you have mass m and the speed of this one is v, so this is kinetic energy 1/2 mv squared. And also we need to understand GPE, gravitational potential energy. This is equal to mg delta h. It simply means that imagine that we have ground. So this is the ground and we place object on this one. Let's say the mass is placed here and the mass is m. If we raise this one to certain height, let's say we raise this one to this height, and we need to calculate what is change in GPE. So simply what you need to do is you will take this height, the change in height. If you take this change in height, you can calculate change in GPE. So change in GPE is mg delta h. So this is how you can calculate. And one more concept and then we go to problems. You also need to understand what is energy conservation. So very important concept in physics. Energy conservation means law of conservation of energy, simply we can say. Energy conservation. Energy conservation simply means that if I say in one sentence, I can say energy remains constant. So I will say energy remains constant means the total energy. So we can say total energy remains constant. So we can say remains constant. So this is law of conservation of energy. It simply tells us that initial energy, initial always equal to energy final if there is no change in mass. So energy initial is equal to energy final. So sometimes you will be using this one, kinetic energy initial plus potential energy initial. This one has to be equal to kinetic energy final plus potential energy final. You will be using this one. Okay, so this is about conservation of energy. Now let's try to understand about power. What is power? So this is also another concept you need to understand. What is power? Power simply is equal to work done per unit time. Means work done per time. Total work done over total time taken. So we can calculate power, and sometimes work done actually is a way to transfer energy. For example, I want to transfer my energy to this mouse. I can raise this one up. So energy of mouse increase and that energy is coming from me. So work is a way of energy transfer. So you can transfer energy from one object to another object by doing work. So that is work done is energy transfer. So you can say work done is equal to energy transfer, and if energy transfer is given to you, you can divide by time this one. So this is the energy transfer. If you divide this by time, you can also calculate power. So this is another way to calculate calculate power energy transfer over time. Now also we need to understand what is unit of the energy transfer, what is unit of power. So this is important concept. What is unit of this one? Unit of power simply is watt. So W we use for this one, and what is the name of scientist? So this one has to be capital W. And work done, for example, work done is equal to FD, and this is divided by time. Now from here you can find out. Actually I want to change the size of this here. So you see this one here, D over T, this is V, so this one is equal to V. So the power is also equal to F times V. So this also you need to understand, power is equal to force times velocity. And the last concept, we need to understand what is efficiency. Very important concept. You need to understand what is efficiency. Efficiency simply means that this is equal to energy out, useful energy out. Very important. So useful is very important. Not only energy out, useful energy out divided by total energy. So we can say energy input. You can also write down this one. P out means useful P out, and divided by total P in. We can also calculate. If they ask you to calculate percentage efficiency, means percentage, you have to multiply here with 100. So that's all what you need to understand about work, energy and power. So let's start working on past paper questions and try to understand these things in a better way so you can answer questions in your exam. I hope these points are clear. So if you have any question, please, until now you can type your question. Otherwise we just move on to next one and you will do past paper question. Okay, excellent. So if you don't have any questions right now, let's move on to next one. Okay, next one. So I'll just go to next. So these points you need to understand. You can take screenshot of this one. We will be using this in our today's class, these formulae. Let's move on to next. Okay, here is question number 1, please. Very nice question about work, power and energy. So can you please try to answer this question by yourself? First of all, type your answer. I will check your answer, then I will explain. So start working on this, please. Start working on this one. Okay, please type your answer. First do by yourself, then type your answer. You have 2 minutes. If you need help, you need any hints, you can also ask me. Okay, question is asking you work done against gravity. So very important point, which work done by gravity against gravity. So which force you need to consider? Gravity. And gravity always vertically up, and always vertically means vertically down. So we need to calculate work done. So hint for you is W is equal to FD. So which force question is asking you to calculate work for which force? That force is gravity, means that is W. I will say force due to gravity, or simply force of gravity, Fg times d. Now in this case, what is force of gravity? Means what is weight of the object? So let me write down here. Weight is force of gravity, means this is the force acting on object by our planet. So is the weight times d. So now in this case, what is the weight? So this weight is given to you. The weight is given, means this much is the force acting on object. So this is the weight. So I can plug in value of weight. So this one is weight. Now which distance we have to take? Gravity always act vertically down, means along vertical direction, vertical. So gravity always act along vertical, means down. So along vertical. So it means that you need to take vertical distance. So what is vertical distance? This distance is vertical. So this distance is vertical. So simply I can say this distance I need to take, because distance moved in direction of force. So I have to just simply multiply with this distance. Okay, and I can find the answer. If I solve this one, so you have 2000 here, and if you multiply this one with 80 divided by 100, so these 2 zeros you can cancel, then 80 times 20, our answer should be 1600 joules. So the answer for this question is B. Okay, so the answer for this question is B. This is the answer, please. I hope it is clear to you. If you have any questions right now, you can type your questions. Otherwise we just go to next one. If you will not type any questions, it means it is clear to you. I will just assume it is clear to you. Okay, so this is how you can approach this problem. Let's move on to next one. Let's move on to next and do another problem. Look at this problem now. First of all, read by yourself and try to understand, and then type your answer, please. Take some time and try to answer it. We need to calculate least amount of work done. Least amount of work done. So simply I can say least amount of work done, we have W. This one is equal to F times D. F times D. Now in this case we have box actually. The force of gravity on the box is the same. So I can simply say the weight here I can write down. Weight is the force you need to consider because the box is moving vertically up. So weight, but weight of the box is constant. It is not changing. So it means this quantity is fixed. We need to calculate least amount. If we make this one smaller, it means this will be the least amount of work done. Now can you find the answer please? In which case D is the smallest. Okay, try to answer now please. D you need to consider small, and D in this case is the height. So in which case we need to do the least amount of work. Least means minimum amount of work. Okay, so please try and type your answer. Be confident. I'm quite confident you have ability to answer this problem. Okay, please. Okay, so let me explain to you now. If you have tried, it's good. If you're still working, you can follow me how to answer this problem. So imagine that if this person move this box to this point, how much this person has to do work? Just move to this point. Let's say this distance is D. You can imagine that this distance is 1D, and the distance between these two shelves we can say is 2D, double D. 1D here, 1D here. So just for simplicity, so I can say this is 2D. So the least amount of work is done when the person move this box from ground to this one. So now we can find out our answer. Here first one, high shelf. No, this is not right answer. High shelf, not. High shelf, this is also not. Low shelf, yes. So this one is the right answer. So this one is the right answer. Mean just place to this shelf. So in this case, this person will do the least amount of work. So the answer for this question is D. Simply you need to understand how to use this form. Okay, this one please, you can see here is the answer. So the answer for this question is D. Let's move on to next one. Next question. Very nice question. This question is really very nice one. It will test your conceptual understanding. So can you please try to answer this now? Very nice question. Again, this question is asking you what is distance. So you need to understand work done. So you need to use W is equal to F times D. F is given to you. Now question here asking you D. What is this D? This is distance moved in direction of force. Distance moved in direction of force. Now you need to understand which distance you have to take. So distance moved in direction of force. So this is the point you need to understand. So does it mean this distance? No, because force is here. This distance is this way. So this is not. Does it mean this? No, because this distance is vertically, but the force is along the plane. So this is not possible. This is not. This one is right. This distance you have to take. So in this case, if you need to find the distance, means the work done, that has to be FR. So the work done by F. We are talking about work done by this force. So work done by each force is different. We are talking about work done by this force. So work done by this force is this one. So the distance you have to take in this case, that distance has to be R. So the answer for this question is C. So the answer for this one is C. Okay, so this one is the right answer. Very nice question to clear your conceptual understanding of what exactly work done is. So this is how you can approach. Let's move on to next. Another nice question, not very difficult one, but very nice question to test your understanding of power and work done. So please look at this one, take some time. First of all, answer by yourself. Okay, first of all, try by yourself and type your answer if you can do this one. Okay, don't be shy, type your answer. It doesn't matter and your answer is wrong or right. I will explain then. Okay, please type your answer. So distance, the force moves the object. Power, what is power? Power is simply equal to work done over time. So this is work done over time. Simply you can say this is FD over time. FD over time. But if you read this question carefully, it is given to you the size of the force is given. The size of the force. So let me move this one so you can see it is given to you. Size of the force is given. So we have value of force. As we have value of force, it simply means that we need only value of D and we need value of time, and then we can calculate power. So in this case, we need distance, means we need this one. We need time, yes we need. So the answer for this question is A. So the answer for this problem is A. So this is how you can answer. Okay, so this is how we can answer. So let me show you the answer. Answer for this question is A. Any questions about this, please? Until now, any question? Okay, if you have any questions, you can type right now. Otherwise, we just move on to next problem. Okay, for this problem, please, this is about power. So here you can see this is given to you. Power is given. Power you need to calculate in this case. So you can see for this question what is given to us. Time is given. So first thing you can write down, time is given. So we can say time is given. Height is given. So this one is the height. And what we need to calculate? We need to calculate power, and the weight of the person is given. The weight of this person is given. Now simply you can start from here. Power. Power is equal to work done over time. So we can say power is equal to work done over time. So work done is equal to force time distance travel over time. In this case, force means that the weight of the person. So force is weight of the person. So we can say force is weight of the person. So this is weight of the person. And the distance person we have to consider. In this case there is no friction. So we no need to consider work done against friction. So we can say W. So W is the weight and height is 5 meters. So this one is the height. I will say H. So this one is the height divided by time. Time taken, we can simply write T first of all. Now we can plug in values. Weight is given, that is 500 newtons. Height is given, that is 5, and time is given, that is 10 seconds. So you can cancel this 0 with this one, then 50 times 5, and we can find the answer. So it means it has to be 250. So the answer should be for this one 250 watts. So it means the answer for this problem is C. So this is our final answer for this problem. So this is how you can approach. So here, so C is the answer. Let's move on to next now. Okay, very nice question. This is also conceptual question, but very nice question to test conceptual understanding of work done and power. So please look at this now and try to answer this one. First of all, try by yourself. Okay, you have 2 minutes. Try this one and type your answer if you can do this one. Otherwise, I will explain. Okay, so let me explain you now. I hope you have tried, so let me explain. For this question, please, you need to understand. Question is asking you need to find out average power. To calculate power, we need to understand it is equal to the work done over time. So this is work done over time. Work done we have to consider. In this case, you see this force is vertically and this box is not moving vertically, means not moving up, not moving down. So it means no work is done by this force. So we have to consider this force, work done by this force. So the force is given, the distance travel is given. So we can say this is FD over time. So the force is 300 newtons and the distance travel is given is 3 meters and the time taken is 20 seconds. So we can cancel this 0 with this one. And 30 we can cancel it too. So we got 15. 15 times 3 means 45. So 45 watts is the power, average power of, means average power we can calculate using this one. So this is the average power. Means energy has been transferred 45 joules per second. So this is what is meant by power. 45. So the answer for this question is A. A is the right answer. So the answer for this problem is A. 45 seconds. 45 watts. Let's move on to next. So this is the answer, please. Let's go to next one. Very nice question about power and also about work done. So first of all, try by yourself. Try to answer this one. Then I will explain. Take some time. Try to answer, please. You need to try all these problems first by yourself. So in this case, for each wheel, this one, please. Each. Simply you can understand for each box. So we will write down first of all work done. So work done is equal to, in this case, work done is equal to force time height. And the force we need to apply to lift this one to the side, that should be equal to the weight if this is moving at constant speed. So it means gravity. Weight has to be equal to applied force. So weight times height. In this case, you can see height is fixed. Box is moving from here to here. So the height is fixed. It means no change in height. Weight of each box is also the same. It means work done is the same. So we will say work done is the same. So this is the same. Now we need to understand power. So power is equal to work done over time. So power is work done over time. So work done over time. Work done is the same we have already discussed. Now we need to understand time. So if you read question carefully, it is given to you the speed is increased. If the speed is increased, it simply means that shorter time will decrease. So in this case, time has decreased, means time taken to lift one box from here to this height. I can simply draw vertically. This time taken reduce. If time taken go down, it means that power will go up. So the power will increase, means energy transfer per second will increase, or you can say rate of energy transfer will increase. So answer for this question, power increase, work done is the same. Power increase, work done is the same. So no change in work done. So answer can be this one, but this is not right because this is decreasing. So the answer for this question is D, no change and increase. So answer for this question is D. Okay, so this one is the answer. Okay, if you have any questions until now, you can type your questions. Okay, let's move on to next one. This is also very nice question. Conceptual questions. Concept is clear. These are not difficult. Okay, try this one please first of all by yourself, and you can type your answer and then I will check and explain as well. So try to answer this please first of all by yourself. So each person has the same weight. Very important piece of information. So when I read this question, I will underline this one, same weight. So it means F will be the same. So we need to find out greatest average power. So the power we need to find power. So the power again is equal to work done over time. So I will write down power is equal to work done over time, and work done is equal to force time distance over time. So in this case, force is the same because force is the weight. Force is the weight. Person has to lift his own weight. So the force he has to apply has to be the same. That has to be equal to the weight. So force is the same. Distance traveled vertically. There is no friction. No work is done against friction. We are ignoring friction in this case, and also air resistance. So it means height is the same. It means distance is also vertical distance is the same. Now we need to look at time. Is asking you greatest power. Power is greatest when this time is shortest. So this one will be greatest. So which has taken the shortest time? Just you need to compare here. Work done each time is the same. So if the time is shortest, it means power is the highest. And so simply answer for this question is C. You see, it's the same concept, only same concept we're using again and again, and we are answering a lot of problems. So the answer for this question is C. Let's move on to next one. This is based on conservation of energy. Conservation of energy. Another very important concept from this chapter. Okay, please try first of all by yourself. Give it try, take some time, and then I will explain. Take some time, try this one. I hope you can answer this. Then I will explain. Okay, try please. Try and type your answer. Okay, let me explain to you first of all. Look at this question now. First thing it is given to you, it's starting from rest. So at point X, object is at rest. When it is at rest, it means U is equal to 0. This is meaning of rest. So if it is at rest, it means kinetic energy at this point is equal to 0. Now we can take our reference point. We can take reference line. I can simply draw one line here. So we can take our reference line. So let's start from here. So this is our reference line. So from this reference line, you can see there is a certain height. So it means this person has potential energy with respect to this reference line. So we can say this person has certain GPE. This is our reference line. It means we are taking F is equal to 0 at this point. So it also means that potential energy at this point is equal to 0. So mgh is equal to 0. So this is kinetic energy. So it will have kinetic energy at this point. Or it is given to you, it stop here. Stop. So it means kinetic energy at this point is also equal to 0. Now you need to understand how energy transfer will take place. First thing, it has GPE. This GPE, this will be converted into kinetic energy. And then kinetic energy, finally, this will be converted into thermal energy. Finally, when stop, kinetic energy becomes 0. So this energy will be converted into thermal energy, or simply you can say heat. But if you say heat is not proper way to say thermal energy. So it's better to say thermal. But at this level, you can use heat is acceptable. That's the reason they have written in bracket. Okay, so what's the answer for this one? You will simply say in this case now, answer has to be A, GPE converted into KE, then KE converted into thermal. So the answer for this one is A. So A is the answer. So answer for this question is A. This is the answer. Okay, let's move on to next one. If you have any questions, please, you can write down right now. You can type your question. If you don't have, we can go to next. Any questions, please, until now? Any questions? Okay, let's move on to next. Another question on conservation of energy. Conservation of energy. Please try this one. Try to answer by yourself. First try by yourself, then I will explain. Okay, for this question, let me explain to you now. Car is stationary at the top of a hill with the engine switched off. At rest. It means at this point, car is at rest. So we can say car is at rest. Kinetic energy of the car is equal to 0. Now it is given to you. Brakes are released and car rolls down the hill. At which level point car has the greatest kinetic energy? We can ignore friction. So again, we can go back and we can draw a line. So we can draw this line. And now from here you can see this is the height. So this one is the height. So this is height h. So when the car is at this point, kinetic energy is 0 and the GPE of the car, we can say this one is equal to mg times h. This is our reference line. We are taking h is equal to 0 here. So GPE at this point is equal to 0. So it means that GPE has been converted into kinetic energy. So this one has been converted into this. So the kinetic energy at this point is maximum, is greatest. So in this case, answer has to be C. At this point, kinetic energy is maximum. So the answer for this problem is C. Okay, let's do one more question and then class will be over. Let's do one more. So answer for this one is C. And this one is the last problem for today's class. And this is also based on conservation of energy. So let's try to answer this one. We have just few minutes. First of all, you can try by yourself. You just need to fill in the blank here. Let me give you some ideas. At this point, it has gravitational potential energy. You can simply imagine that like this. This is the pendulum. If I move this way and let it go, it will oscillate like this. So here GP maximum, at lowest point, kinetic energy maximum. So it will have GPE at this point. Now, you also need to consider if you take, this is the reference line. So I will take this one is the reference line. So this height is h1. So we can say this height is h2, for example. At this point, we can say this height is h1. And here, this is the reference line. So when object is here, it has GPE. That will be equal to mgh1. At this point, it will have kinetic energy and also it will have GPE. GPE is not 0 at this point because reference line is here. So GPE will be equal to mgh1 and this is h2 actually. This is mgh2. This height is h2. So now you can answer this problem. So kinetic energy at this point, it has kinetic energy and it has GPE, potential energy. It has also potential energy and energy loss, and energy loss is at x. So the answer for this problem has to be B. So B is the answer. So when we define gravitational potential energy, we always take a reference point. Most of the time, ground is a reference point. So with respect to ground, it is still at a certain height. So when it is at this point, it still has potential energy. That's all for today's class. I hope you have some better understanding of this chapter now. I'll see you in next class. Bye for now.